All right, guys. So here's where we left off last time. We're going to talk a little bit about molecules, compounds, stuff like that. We're going to get into water, and then we are going to talk very briefly about acids and bases. So, molecules and compounds. All right. So here's the thing. All molecules, all compounds are molecules. All right. So if a compound, which is two or more things together, or different things together, all right, that is a compound. It is also a molecule because a molecule is just a group of things coming together. Okay. Now, not all molecules are compounds. For example, chlorine gas, fluorine gas, all right, hydrogen gas. Helium is a noble gas, so it really doesn't bond with anything. These are all molecules. However, they're not compounds. Okay. H2 is called diatomics, and you'll learn more about this when you get into chemistry. They are a molecule, two things put together, but they're not a compound because they're not different chemicals. So we talked about this yesterday. Salt, or the last video, salt, NaCl, and H2O, water. All right. So that's, one of the main differences between those two. Now we also have mixtures, okay? Mixtures are just two compounds, salt and water, for example, that are physically, not chemically mixed, okay? So when I pour salt, here I got my little cup of water, and I pour salt in there, all right, it is a mixture now. Now, more specifically, it is a solution, but we'll talk about that in the next slide, okay? But they do not chemically mix. This is not breaking of bonds per se. These bonds are going to stay together, all right? They're just going to mix together. So in a solution, you have a solute, which is the thing getting dissolved, and then a solvent, usually the thing doing the dissolving. A lot of times it is water, and it is the universal solvent. We'll talk even more about it on down in this video. All right, so there's solutions. Then you also have suspensions right here. All right, suspensions mix, but only for a period of time. Not evenly. So what I mean by not evenly is they're going to usually separate back out. So the best example I always give, and we'll do this example in class, is oil and water. So if I have my little beaker, I got oil, water. I can mix these up till I'm blue in the face. Give it time, and it'll always separate back out between oil sitting on top and water sitting on bottom. Okay. Every single time, without exception, no matter what, is going to happen. One of the reasons, and we'll talk more about this, especially in the next video, is oil is nonpolar, so it has no charge. Water is polar. We talked a little bit about that last time, but we'll talk more about it today. All right, so they don't really mix well together. One of the reasons salt and water mix together so well is because they both have a positive or negative or poles, and so that kind of helps them dissolve up better. All right, so all about water. Once again, H2O means it's 2 parts hydrogen, 1 part oxygen. Water is polar, which means that bond, that covalent bond that they share, is unevenly distributed. Remember, oxygen is 16 times larger than little old hydrogen here. Okay, so that means that this guy will unevenly share that electron. We remember from the last video, electrons are negative, so that means this ends up being slightly negative charge, This ends up being a slightly positive charge. It's different from ionic, where we had a full negative and a full positive, because remember, we transfer electrons, we give them over. Here, we're not giving them over, we're sharing them, so we get a slightly negative and a slightly positive, causing it to be polar, like Earth has poles. Now, this polarity allows water to be the universal solvent, because anything that has a polarity to it will be easily dissolved in this substance. Okay, so once again, kind of draw like here, we have our water. Let's draw. So I have my water, negative, positive. All right, and then I have my sodium, which has a positive charge, chlorine, which has a negative charge. So you can see here that this chlorine is going to be kind of attracted to the hydrogen portion. The sodium is going to be kind of attracted to the negative. And so this is going to help them dissolve really evenly. Now, water is said to be sticky. The reason is that hydrogen bonding that we talked about last video. Remember, once again, reiterating this for the 20th time. Slightly negative, slightly positive. That slightly negative, slightly positive portion is where we form this hydrogen bond. Okay? So this hydrogen bond allows water to have some pretty cool properties. The two main ones we'll talk about are cohesion and adhesion. Okay? Cohesion is water molecules attracted to themselves. Adhesion is water molecules attracted to other things. Now, you've probably heard the term cohesion, adhesion, especially a lot of us here at Marist, we play sports. So your coach might say, we got to come together as a cohesive unit. And the reason he's saying it and using that terminology is because you are all water molecules, okay, aka, all right, because you're all on the same team. You all play for Marist soccer, and you all work for a common goal of beating Pius, all right. So you're all coming together to work on this common goal, all right. So that is cohesion. Now, adhesion, coach might say, you got to adhere to the game plan. Okay. Well, adhesion, the game plan itself, is something different than y'all as soccer players. So it's adhering to something else. So, aka attracted to other things, and therefore adhesion. So these two properties allow for some cool things. Like I said, high surface tension on water as a result of the hydrogen bonding. Surface tension is more directed towards cohesion than adhesion. So if I have like a little cup of water, if we've probably all done this, it'll fill it up and almost overfill it, but it has like this little bubble on top. Okay, that is the cohesion of the water adhering to itself. Okay, we'll do a lab with all these that we can kind of have a better visual context for them. And then when adhesion and cohesion work together, we get capillary action, which is where water kind of moves against gravity to move up, like it is here. So if I were to take a empty like toilet paper tube or paper towel tube and stick it in a glass of water, eventually that water is going to climb slowly up. All right. And over time, it'll fill all the way up here because the water is adhering to the sides of the paper towel, but it's also cohesive, so it's kind of pulling its little buddies along here. All right. This is a great thing because, especially when we get to plants, plants have what's called capillary action. They have these little veins, or better, like a better term, called xylem and phloem, and they're like the blood veins of a tree. Now, they're very small little tubes, and as water evaporates from here, aka transpiration, water is pulled up behind it. Okay, so we love capillary action because we love plants, because if we didn't have plants, we wouldn't be here. And not like in a vegan manner, aka they wouldn't make any oxygen and we would all suffocate to death. All right, pH. We're going to do a quick little look at pH. We're going to delve much more in depth in it in chemistry next year. All right, so pH is a scale to determine acidity and basicity. Okay, kind of 0. We'll see this in the notes, so you don't have to write any of this right this second. 0 through 6, acid. 8 through 14, base. And honestly, even if you want to get really super technical, 7.1 would even be a acid. This is 7 is dead neutral, like 6.9 would be also slightly acidic. But we just say 0 through 6 and 8 through 14 as acids and bases. Now, we'll get, like I said, you're going to get a lot more into it next year. So what you need to know is acid forms H plus ions in solution. So it's going to give over H plus ions. This when water, take water. Okay. Water, it will break apart. All right. And when it breaks apart, you end up with H plus or OH. You end up with hydroxide or hydronium ions. All right. And so if it forms in solution, it gives off H plus. That's going to be an acid. If it forms OH in solution, it is going to be a base. That's it for properties of water, a little bit more about bonding, and we will pick it back up at macromolecules, aka carbohydrates, fats, lipids, and proteins, also nucleic acids.